Hello everyone in the class. Since many of you asked the question about the proof of logic identities, especially this last question, proof by contradiction, this question, I will go over this problem. Okay, and proof by contradiction goes by the philosophy that if this assertion you want to be proved to be true, by contradiction you say you are supposed to be not true. And then you use your logical rules and come to the conclusion that there is a contradiction. So if not true, there's contradiction, then it must be true. So let's go over this problem. So suppose this is not true, so therefore they can have different values. On right hand side can have 0, and then at the same time the left hand side have 1. So if that's the case. So I give you a question why I said that way. You could have easily said, well, this side is 0, 1, the other side is 0. But the strategy is set to 0 this side and 1 the other side because I have a OR here. Now the step is to use this first one. Okay, so since it's the OR is 0, by this junction rule, if a OR is 0, only case is that both sides are 0. So therefore, from 1i, a is 0, b and c are 0. See, that's why I set to 0 instead of set to 1. If that's 1, you still don't know which side is 0, which side is 1. Well, maybe both 1. So you cannot get any conclusion even though you are correct. So since this is 0 by this OR here, and this is 0, the other side is 0. Now we can get it from the second one, we set to 1 since there's an AND here. If this is the AND, both sides, both this one and that one must be 1. Therefore, from 3, 2, so A or B is 1, and C or A or C is 1. That means from here, that must be 1, and this also must be 1. So that's the conclusion. Then let's move on. Then now, these are also derived, correct. So then from 2, we have 2 and 3. So 2, we have A equals 0, and 3, we have A or B equal 1. So see that, look, A is 0. Now this is 0, B must be 1. So therefore, that's the OR. So that's a disjunction. And so now, same idea, A or C. Now A is 0, so A is 0, so C must be 0. C must be 1. That's again by the definition of disjunction. Now let's move on. So we have B equal 1. So from 4, from above, we have C equal 1. So that's correct, right? From B, we have B and C equal 0. From here, you see, from B and C is 0. So B and C is 0, and C equal 1. So see, think about that. This is 1, that is 0, and then B must be 1. B must be 0. So basically, that's the conjunction. The reason, okay, I put my convention, the reason to get this step, I will put it here in capital. So B equals 0 because C is 1, and you have from 2, B and C is 0. So because that is 1, the problem must be this one. That must be 0. So B equals 0. So then everything follows strict logical rule derived from this point. And now we observe the contradiction. So over here we have B equal 1. Over step 5 we have B equals 0. The contradiction is observed. Okay, that means one has to equal 1 while the other one has to equal 0. Therefore, from here, if it's not true, here is a contradiction. Therefore, it is proved. So that's the strategy, or that's the proof. Okay, there are other ways to prove. I saw they're equally correct. I can have like 3 or 4 ways to prove it. But the philosophy is always true. You assume it is not true, and then you use basic laws. And the trick is, the strategy is using AND. So if you see a OR, you say, well, the whole thing is 0, and then you immediately have A equals 0, B equals 0. And if you see an AND, you say, well, this is, let's say this is 1, and this side is 1, that side must also be 1. Okay, hope that's helpful. I hope you enjoy playing with this. Bye bye for now.